Hi students, it's Miss Vernon, and I'm here today to teach you about solving equations. And we're going to specifically look at solving equations that are quadratic. You just learned how to factor and work with equations and polynomials in different ways. So now we're going to take those skills and integrate them into solving, so specifically solving quadratic equations. Graphically does not require the skills you just went through, but the algebraic approach will require you to utilize those skills. So let's begin by seeing what you already know. So here I have a graph, and I'd like you to pause the video and write down anything you can about the graph. Tell me anything you think you know. All right, upon returning, I'm just going to jot down some things that students usually comment on. They usually tell me that this is a quadratic. There we go. And they tell me that it's opening up. They also tell me that because it opens up, that the a value or the coefficient in front of the x squared is going to be greater than 0. So therefore, it's going to be positive. They tell me that there are no x-intercepts. They tell me that there is a minimum of the graph. Some of them tell me that there's a minimum more specifically at the value 4, 3. So they identify that point of that minimum. We already know quite a bit about graphs, but part of what we do in today's lesson is going to be helping identify those things algebraically so that we have more tools in our toolbox to use as we work through our math this year. So let's go ahead and jump into the lesson. In P5, we are going to be focusing on solving quadratic equations. We're going to highlight a few of the different techniques that we have. So to begin, many students will tell me that the first thing they do when solving a quadratic equation is they jump in and they use the table method. Now, the table method is not a great method because it's not very effective. And what I mean by that is if your answer is a decimal, it's going to take you a long time to narrow in. It gives you an idea of where the 0 or the intercept might be happening, but it doesn't really help us. So I'm going to really discourage using the table. You can use the table if you feel like it helps you narrow it down or check your work, but really we're going to be depending more on option 2 and option 3. In option 2, we are going to talk about graphically. During our live meet, I will show you how to do that, but on our recording here, I'm going to use Desmos to help us out. And then algebraically today, I'm going to be focusing on solving it using the factoring method, the zero product property, and the quadratic formula. In tomorrow's lesson, I will talk about completing the square. So let's just highlight a couple things about the graphical approach before going into the algebraic ones. So in the graphical approach, there's a couple things you'll want to remember. The first thing you'll want to remember is that the x-intercepts and the y-intercepts are going to be used to describe the graph. It's going to be helpful to know where those are, if you can see them off the graph, or how to recognize or find them algebraically. For example, to find the y-intercept, you're going to let x equal 0. And to find the x-intercept, you're going to let y equal 0. So those are two quick little tips I can give you now. If you're not able to see it on the graph, that's how you can work with it algebraically. Again, I highlight that here, but I also identify that x-intercepts are also known as or referred to as the roots of the graph. It's basically where does the graph cross the x-axis? The y-intercept is helpful as it gives us its starting position. And as I said, this occurs when x equals 0. Let's take a look at a graph that I have for us here, just to reference a couple of these vocabulary words. So here you see we have our maximum, and I've identified this one on the graph as 0.5, 24.5. We've also identified the y-intercept as where the graph is crossing the y-axis, and we have our x-intercepts, and that's where the graph is crossing the x-axis. When we talk about the algebraic approach, we're really looking at solving an equation if it's in general form. Now, we can solve equations in other formats that are quadratics, but we're going to take a look at those a little bit more during our class session. So ax squared plus bx plus c equals 0. Note that usually the a, b, and c are going to be numbers. In most of our algebraic solving, it's really important that we make sure that it ends up being set equal to 0 prior to using the method. Otherwise, the method will not work. In our first option, we have the factor and then use the zero product property. I like to call the zero product property the ZPP. The ZPP, or zero product property, says that if I have two terms that are being multiplied together and they equal 0, then either term A has to equal 0 or term B has to equal 0. Another method that we can use to solve algebraically is called completing the square to solve. I'm going to highlight this method tomorrow in the Edpuzzle for class. The third and final method that we have for algebraically solving a quadratic equation is to use the quadratic formula. Again, when using the quadratic formula, it's essential that we make sure that it's set equal to 0 prior to applying the formula. Otherwise, it will not work. In the quadratic formula, we've all heard the song, but I'll sing it one more time for you. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you get that tune stuck in your head. It's not uncommon for students to bob their head to that tune as they're doing the problems. All right, let's jump in and do some solving together. I have 3 examples for us to work through today. The first example is going to be to solve this problem graphically. When solving a problem graphically, you are able to use your graphing calculator. That would be the TI-84 or the TI-83. And I will highlight how to do that in class today. For today's lesson, though, I'm going to utilize Desmos. So what I've done is I went into Desmos.com and I just typed in our equation. Now, typically when you type in the equation, your graph might not look like mine does. What I did to adjust my graph is I went up to the wrench and I adjusted the X and Y axes. I often see students who will do this zoom out and zoom in thing. That's not always the most effective approach. Going to the wrench allows you to adjust the scales by typing in numbers. For example, I might want my scale to go from -6 to 6, and I want it to increase by increments of 1. On my y-axis, I only want it to go from -10 to, let's go to 15. But this time, I want it to go by increments of 2. You can see that your graph will easily and quickly adjust. Now, the cool part about using Desmos when you are solving graphically is you can click on the point and say, hey, look, that's the y-intercept. When you click on the graph, it will easily identify your values of interest. So you can see our solutions to this graph are -0.5, 0 and 2, 0. Notice that Desmos writes your points as a point and not as an x equals. So again, our answer from the graph was 0.5, 0 and 2, 0. Sometimes you will see students who will write this answer as x equals -0.5 and x equals 2. As long as you are noting that you are finding your solutions or your x-intercepts, you're fine to write your answer in either format. All right, in the next example, we will be looking at finding our answer by factoring. Notice this is the same problem that we went over just a minute ago on the graph. But this time, we're going to use the factoring technique. So when you are solving a problem by factoring, the first thing you'll want to do is check, is it set equal to 0? In this case, it is, so I've checked that off my list. Next, I need to factor this quadratic equation. I'm going to use the skills we learned in the previous lessons. I'm going to use the magic questions to begin. There is no GCF, so I can begin by saying what adds to equal -3 and multiplies to equal the product of the first and the last term. In this case, that's -4. I like to list my factors of what it's multiplying to because it makes it easier. 1 times 4 is 4, and 2 times 2 is 4. As I look at my two options, I know that this is the only factor that's going to allow it to multiply to a -4 and add to a -3. I'm going to have to make the 4 negative and the 1 positive. Now I am ready to put those values into my sneaky square and do my solving. When I go ahead and do this part, I'm going to place the first term in the first box and the last term of my quadratic in the bottom right-hand box. My magic questions are going to add to equal the middle term. So notice that -4x and 1x equals -3x. So far, everything is checking out great. I'm now ready to do my factoring. As I look horizontally at these two terms, I see they both have an x in common. Now I like to ask the question, what times x equals 2x squared? That's 2x. What times 2x equals -4x? That's a -2. And what times -2 equals -2? Well, that's a 1. Now that I've successfully factored, I can rewrite my problem so that I can see it as a product of two binomials. 2x plus 1 times x minus 2 equals 0. This is where the zero product property comes into play. I have two terms that are multiplying to equal 0. So I'm going to set each term equal to 0 and solve. When I do my solving, I quickly find that my answers match what we got from the graphical solution. X equals -1/2, which is the same thing as -0.5, and x equals 2. There you have it. We solved using the zero product property. A couple quick reminders before we go on to our last example. Be sure that your quadratic equation is set equal to 0 prior to factoring. Remember to apply our factoring techniques that we learned in an earlier lesson. And once you have it in factored form, set each factor equal to 0 and solve the remaining part of the problem. All right, I have one more example for us, and that is solving using the quadratic formula. Recall that the quadratic formula also requires us to be set equal to 0. So therefore, I need to make sure that I move the 5 to the other side. So I have 3x squared minus 6x minus 5 equals 0. It must be set equal to 0 in order for me to use the quadratic formula. The next step to solving with the quadratic formula is to determine your a, b, and c values. Writing these out helps us to have more accuracy when we go to do our solving. Remember, the a term is attached to the x squared, the b term is attached to the x, and the c term is the number or constant at the end. Now that I've successfully identified my values, I can plug them into the quadratic formula. That is x equals -b. That means I have a -6 plus or minus the square root of b squared, that's -6 squared. Notice I put it in parentheses to make sure that I don't lose that negative sign. And then it's minus 4 times A times C, all divided by 2A. So 2 times 3. Next, we're going to do our simplifying. When students simplify this, I encourage them to type in everything that is under the square root symbol all at once. When we do this, the first 6 becomes positive because 2 negatives make it turn into a positive. Next, I got the square root of 96 when I multiplied out all of those numbers, and that's all divided by 6. Now I see that I have a square root of 96. We learned how to simplify radicals recently, so I'm going to step off to the side of my problem and simplify this radical. I know that the square root of 96 can be made up of the square root of 16 times 6. I just took my calculator and divided 96 by perfect squares until I got one that worked out. Because the square root of 16 is 4, I can rewrite this as 4 times the square root of 6. So I'm going to bring that back into my problem. I have 6 plus or minus 4 times the square root of 6, all divided by 6. We are now ready to identify our final answers. Remember, we always want to reduce when solving. I am going to write my answer as my 2 separate values that we get. So I have 6 plus 4 square root of 6 divided by 6, and I have 6 minus 4 times the square root of 6 divided by 6. Notice that I can reduce these 2 terms. When I go to reduce, I can see that both of my terms on the top need to be divided by that denominator. When I do the reducing, I get 1 plus 2 root 6 divided by 3. Notice that in the second highlighted part, I just reduced the fraction 4/6. The square root of 6, I can't touch, and this whole entire term is considered one fraction. So I'm only reducing the numbers that are in front of the radical. I'm going to do the same process for the other problem. So again, I see that I have to divide both of the terms on the top by the term on the bottom. When I do this division, I get 1 minus 2 square roots of 6 divided by 3. These are your final answers. Now, some students tell me, Ms. Vernon, I don't know what this looks like on a graph. You can definitely do an approximation if you would like when graphing, but when it asks for the exact answer, they want us to keep that radical in it. I hope today's lesson was helpful, and tomorrow we'll highlight completing the square. Have a great day. Bye now.